We have this question on additional mathematics coming on the topic called coordinate geometry. So the question reads, in the following diagram, PQRS is a quadrilateral with an area of 13 square units. Q is the point, this is the coordinates for Q, for R are these, and the equation of the line RS is 4y equals to x plus 12. So this is the diagram given for the quadrilateral. So the first question said, find the equation of the line QS. So when you look at this line QS, we only have the coordinates for Q, but for S we don't have. So the first thing here is to find the coordinate for S. How? As you can see in this Cartesian plane that we have, X in y-axis it's always 0. So we have already found the coordinate for X, which is 0. Now how can we find for Y? We will use this equation here. So where there's X, let us put 0. So this is what I've done here. First thing, you find the coordinates for point S. So 4y equals, so where there's x, put 0 plus 12 there. So 4y here, now let's try to make y the subject of the formula. So divide both sides by 4. Then 4 into 12, that is 3. Here this they will cancel. Then the coordinates for S, it will be 0, 3. So now let's use the coordinate for Q and S to find the gradients. So you write the formula for the gradients. Let's assign this coordinate that we have as x1, y1, x2, y2. The reason why we are doing this, so that it will be easy for us to plug it or to use this formula very well. So our y2 it's 1, put 1 there. Our y1 it's 3, put 3 there. Our x2 it's 6, put 6 there. Our x1 it's 0, put 0 here. Then 1 minus 3 it's negative 2 over 6 minus 0 is just 6. So here we can still simplify this further. So 2 into 2 it's 1, 2 into 6 it's 3. So then our gradient it's this one. From here now we write our equation of a straight line. So we can use this one where we are supposed first to calculate the y-intercept, but I'll use this one which is more direct and straightforward. So I'll use these coordinates for S. So here I'll write this one. So y minus y1 equals to mx minus x1. So this one it's our x1, there it's our y1. So we'll plug in this equation. Remember our gradients that we are using here, it's negative 1, 3. So after we have plugged in here, it will be y minus 3 equals to negative 1 over 3, x minus 0. Then here we multiply this by this, we'll have this. Since here this one it was negative, when it goes the other side it becomes what? Positive. Then here we don't want to leave our answer in fraction, so we'll multiply 3 throughout. So 3 times y it will be 3y. 3 times negative 1 over 3x, it will just have negative x here, plus 3 times 3 it's 9. So this is the equation for QS. This is the equation. So let's go for how to find the coordinates of the point coordinate of the point P. So this is how you go about finding the coordinates for point P, the coordinates for this one here. So the first thing here, we'll use the area of triangle. So this is the formula for area of what? Triangle. So first thing here, we'll calculate the area of triangle QRS QRS because we have the coordinates for S and RQ. So this is the formula to use. So let's calculate the area of triangle QRS. So we use this formula here. This is our coordinates here. So we'll be just plugging the values there. We use this formula. So this is our x1, y1, x2, y2, x3, y3. So from here we say the area of triangle QRS for this it will be 1 over 2 modulus, they will be in modulus, then 6, that is our x1, they are open brackets, our y2 it's 4, then our y3 it's 3, you put it there plus. Here where there's x2, put 4, it's here, 4 open bracket, 3 minus 1 there, you cross plus. We are just following this formula here. Then from here, we have 1 over 2 modulus. So here 4 minus 3, it's 1. 1 times 6 to be 6 plus 3 minus 1 here, it's 2. 2 times 4, it's 8 here to be 0. So we'll just write this one. So here we'll add 6 plus 8, which will give us 14, 1 over 2. Then we'll remove the bars there. So 2 into 14, it will be 7 square. So now we have found the area of triangle QRS. Now from here, in the question here, we have been given that PQRS is the quadrilateral with an area of 13 square units. So we need also to find the area of PQS. So how are we going to do that? So the area of quadrilateral PQRS is given as 13 square units in the formula. So the area of the quadrilateral is the sum of the area. So the area of the quadrilateral is the sum of the area of triangle QRS and the area of triangle PQS. So this is how we are going to go about it. So this is the formula here. The area of triangle PQRS, which is the quadrilateral, this should be equals to area of triangle QRS plus area of PQS here. Then this one we have been given for the quadrilateral, which is 13, equals to this one we are from calculating it 7, we put it there plus. Then for this one PQS, it's the one that we are looking for. So let's try to make this one the subject of the formula. Then 7, it will go the other side, so it will be negative. So it will be 13 minus 7, it will give us 6 square. So now we have the area of PQS. So in order for us to find the coordinates for P, we need to express the area of triangle PQS in terms of the coordinates of P. So this is how we are going to do it. So this is the formula that we are using. Then now this is our coordinates to use here for P. Here, since we don't know, so we'll just say we'll put just P there, comma 0. So why have I put 0 here? We know that y coordinates in x-axis here. In other words, y-axis in x-axis here, it's 0 here. So in short here, we are looking for the coordinate of P, comma 0, because y in this line is 0. So this is how we are going to go about it. Say the area of PQS equals to 1 over 2. This is the formula there, and this is the coordinates to use. So we'll be just plugging here using the above formula there. So have equals to 1 over 2 here. 1 minus 3 to just give us negative 2p plus here to be 3 times 6, it's 18. Here it's 0, then we forget about it. So our area here it's 6, so we'll have this kind of thing here. Then let's multiply both sides by 2 so that we remove this fraction. Then 2 by 6, it will be just 12. 2 by half here, it will be just 1. So we remove the modulus here. Now have negative 2p plus 18. So here we have take negative 2p the other side. So it will be positive 2p equals to 18. This one comes to the other side, then it will be negative. Then 2p over 2 equals to 6 over 2 there. Then we simplify this, we cancel, even there we cancel. So 2 into 6 is 3. Then our coordinates for p will be equals to 3, 0. And it is true, as you can see here on the diagram here. So we have 3, 0. This is our coordinates for p. Thank you very much for watching.